Alright, here we are on lesson 10, the mean, absolute, deviation, or the MAD. So in the opening exercise it says the following temperature distributions for 7 other cities all have a mean temperature of approximately 63 degrees. Which distribution has the smallest variability of the temperatures from its mean of 63, and explain your answer. So we're looking at 63 in all of these graphs. And the smallest variability means we want as many points as possible close to the mean. So when you look at this first one, even in city A, you see city A, all of the points are on 63. And just by glancing at all the other ones, you can see that they're more spread out. So the answer would be city A. And that's because all data points are close to 63. Alright. Number 2 says which distributions seem to have the most variability of the temperatures from the mean of 63. So now we're looking, and write this down, for the data points that are most spread out or far away. So when we go take a look at all of our graphs here, we're looking for the ones that are very spread out. So we know city A is not city B. They're all pretty close together, even in city C. City D, though, we start to get some dots that are further out from the center. City E even, because nothing is quite close to 63. City F, the same thing. But city G, you can see that most of them are close to the mean. So for number 2, we would say city, and it's D, E, and F. And we would say that the data points on these graphs are the most spread out and farthest away from the mean. Okay, so once you have that written down, go ahead and flip the page, and we're going to take a look at example 1 here. Example 1 says the dot plot for the temperatures in city G is shown below. Use the dot plot and the mean temperature of 63 degrees to answer the following questions. So first, we're going to look at this table here. So this lists all of the temperatures, and then we have to find the deviation from the mean. So we know the mean is 63. So if we were to fill in the rest of the table here, we know 64 would be plus 1, another plus 1, plus 1. 68 would be a plus 5, and another plus 5, and then 70 would be a plus 7. So remember to check the sum. We're going to combine all of the negatives here. So 10, 16, 19, negative 22 here. And all of the positives make positive 22. So our sum would be 0. And then part B says, why should the sum of your deviations column be equal to 0? Because the mean is the balance of the data. Okay. Part C here says another way to graph the deviations is to write them in a number line as follows. And then it asks again, what is the sum of the positive deviations? So the deviations to the right, and we know that was positive 22. What's the sum of the negatives? That was negative 22. And then what's the total sum? Still 0. So this triangle here represents the mean. This is just another way to represent your data using the deviations. Alright, on the last page here, this is really what we're getting at. So D says if we change the negative deviations to their absolute values, would the sum still be 0? And we know the answer would be no, because all values would become positive. Part E says to find the sums of those absolute values of the deviation. So we know that the one sum was positive 22, so the absolute value of positive 22 is just 22. And then the other one would be the absolute value of negative 22, which would again be 22. So if we added those together, 22 plus 22, we would get 44. And now F says to find the mean of the deviations by dividing the sum, which was 44, by the number of deviations, and we had 12 deviations. So 44 divided by 12 is 3.7. This is our mean absolute deviation. So mean, meaning that we were using the means. The absolute, meaning we took the absolute value of the deviations. So that's where the name comes from. So then again, the mean absolute deviation is just the average distance that all the data values are from the mean. Okay, so that's all we're going to do in the video. We will do this part in class tomorrow. Okay, and we'll do some more practice in class altogether.